Good morning, student. Am I audible?
Yes, sir.
Okay. Have you all joined? Do you know how many students of in this batch? Do you have any idea how many students in this batch? No. Okay. Okay. Uh, our topic is DIP, Digital Image Processing. In today's session, we'll discuss what is a digital image and why do we need processing. What are the benefit we will get after the image is processed? So, and what are the different techniques is used for processing and digital image? What is the need of it? Why digital image processing? And what are the benefit we will get after the an image is processed? And what are the different techniques is used for this purpose? So, uh, on the first slide, digital image processing. Let us come to the introduction. So this is a uh, uh, statement. One picture is worth more than 10,000 words. Uh, uh, do you agree with the statement? The truthness of this statement? Is it true? Is it true? One picture is worth more than 10,000 words. Are you agree? So obviously, yeah, I think it is true because the one picture is tells more meaningful than many words. That is why uh, when you present some things, there are it is advised to you that is you have to introduce some more pictures, more graphical things to your presentation because one picture is understand by the many peoples than the words. So one picture is worth more than 10,000 words. I think this statement is true. So that is a picture tells more things than the general words. So that is why uh, uh, we come to an image. Let us first discuss what is an image is. What is the general definition of an image? Image is a representation of something or someone. It may be any drawing, maybe any painting, maybe any photograph, anything can represent something or represent something is an image. You see, there is a image in my presentations. One is a presentation of flowers. That is an image. That is an image. It shows something. It represents something. It may be any drawing, may be painting. You may paint anything or any photograph. So that is an image. When you take a photograph of your camera, of a mobile phone or any other camera, So that is out of an image. So image is very powerful tool communication. So image is a powerful communication nowadays. So we can send you see now any image to our friends, to our group in WhatsApp. There are some images. That images is very powerful tools in communication. It may be black and white. It may contain two color, black and white, or any other color that you know that the basic component of RGB, uh, and when the different ratio of RGB, different portion of ratio of RGB are combined to form a million of words, a million of colors. So an image may be only two colors, black and white, or the combination of any color. And so that is this color may be formed from the basic component of red, green, and blue, and different ratio of RGB are combined to form a million of colors. So a image can be consist of only a black and white color, or any other colors it contain. So the next one is, what is digital image? So far we have discussed what is an image is. Now what is a digital image is? You see the definition. A digital image is a representation of two-dimensional image as a finite set of digital values called picture, elements, or pixel. So it is nothing but it is a 2D representation. You got that is a digital image, the representation of two-dimensional image. That is on the screen. You can uh, mm, uh, mm, represent it by some digital values called picture element or pixels. We are very popular with the word pixels, which is known as the pixel elements. Although there are some other words to represent that pixel, we will discuss about the next slide. So it is a digital image, that is when it is a representation by a two-dimensional. The two-dimensional value we will discuss about detail. You see the figure. Uh, uh, so that is a picture is there, and it is now representing in a screen, in a two-dimensional screen, with it contains two values. One, it is a location, the pixel location, and the pixel value. Uh, and the pixels, it has a location and it has some value which is known as gray labels, colors, height, opacities. These are the different value represented by a pixel. So do not confuse. We will discuss about these terms uh, in coming slides. So now you see what is the digital image. This is the definition mathematically. When x, y, and fxy are all finite discrete quantity, we call the image as digital image. What is xy? As we know, the image is a representation of a 2D dimensional. X and y represent the location of the image. Location of, suppose, a particular pixel. Every pixel has a location on the screen. 2, 5, 3, 5, whatever may be. Every 5 location. That is called x, y. And every pixel associated with a value. It is gray label value. It's color value. So always a pixel is associated with two things. Remember that these two things. One is the location, which is represented by xy, X is the value in X coordinate, Y is the value in Y coordinate. So this is first thing, location. Second thing is f of xy. F of xy means value at xy. What are the value of that pixel at the point xy, that is represented by f of xy. That is represented by f of xy. It represents a gray value. Gray value means the white and black, any color values. This value represent that things. What are the color value of that? You know that the gray label value is 0 to 255. We'll discuss about that. What are the gray label value? What are the range of the gray label? We'll discuss about that. But this is important. Here we know that the xy is the location of the pixel, and f of xy is the value of that pixel. That value represent the gray label values or color values. So digital image is composed of finite number of elements, each of which has a particular location and value. Particular location and value. I am emphasizing this. Every pixel has a location and value. Where it is represent, where it is situated, that is location, and what its value. Value means its gray label value, its color value. These elements are referred to. This pixel may be termed as in somewhere pixel element, in somewhere image elements, in somewhere pales, and more widely used pixels. So generally pixels, the word pixel is more widely used for that, but in some books or some sites, websites, you will get picture elements or image elements or pales. Do not confuse, or all the four terms are same or equivalent. You see, and we will get more clear about the digital image here. You see, the where x and y represent, you see there is a x coordinate, there is a line of x0 and y0, and the intersection line, assume that this is x0 y0. In the first picture, I am discussing about the first picture. You see there is a line x0 and y0 to x0 x-axis and y-axis, and suppose the intersection point is point of x0 y0 at the location, that is the x0 y0 on the screen, and value of that x0 y0, the value of x0 y0, that is what is the color or what is the gray label values of that point x0 y0 is known as fx y0, f of x0 y0. So the point itself is x0 y0, and the gray label value or intensity value, which lies between 0 to 255, we will discuss more about that, is known as the intensity value, gray label value, and represented by f of x0 y0, f of x0 y0. Similarly, come to the second picture. They are plotting there x-axis, y-axis, x1, y1, and the intersection point is x1, y1. It is another point of that pixel, of that image. It is another pixel of that image. Pixel is nothing but it is a picture element, and it is the smallest unit. It is the smallest unit of an image. Like you know that a point is the smallest unit of a line. In our geometry, general geometry, we know that the point is a smallest unit of a line, a circle, anything. That is a line is a combination of several points, and a points is a smallest unit. The points cannot be divided further. Similarly, in an image, in a digital image, the pixel is the smallest unit. We cannot divide it. We cannot divide the pixel into the smaller parts. some pixel combines to from megapixels. You know that the MP, megapixel, gigapixel, you know that. But the smallest unit is pixels. So I am here discussing about the pixels. And you see the pixels here is x1 y1. In the previous picture it was x0 y0 and its value is f of x0 y0. Similarly, in the second picture, its location is x1 and y1. The location is x1 y1 is another pixel in that image. It's not x0 y0. The x0 y0 and x1 y1 are different. And also f of x1 and y1, f of x1 and y1 is also intensity level or gray level value of the pixel x1 y1. So every pixels have the its own gray level values. So a pixel is associated with two things. One it is location and value of this pixel at that location. xy f of xy, like your x0 y0 f of x0 y0, x1 y1 f of x1 y1. So this is the mathematical definition. If you ask what is digital image, you can say that a digital image is consist of some elements that is known as pixels, and every pixel associated with two components. One is its location, another is its value at that location. So every pixel is associated with two components. So this is the proper definition of a digital element. Are you getting me?
Yes, sir.
Okay. So the summary of the class is so far discussed. That is what is an image, what is a digital image, and what are the component. The main component is pixels, and an image is consists of some image, and every image is associated with two things, two components, as we discussed, the locations and the value at that corresponding locations. Okay. Then you see some image. The image types of image. So image are classified into different categories basis upon different components, different criteria. The first one is attribute. That is, if we divide the image in attributes, that is, you see vectors, the vectors image, whose vectors files are most useful when graphic needs to be able to handle resizing, as is written crisp detail when scaled to any size. So if you want to resizing your vectors, the image, so the vector image is suitable. Vector format is also an excellent choice for digital illustration such as logos. A vector file can be converted to the, we will discuss about the raster file, but a vector image can be converted into the raster image, but it will permanently lose the advantage of the vector format. So once it is converted, it can lose its property. And some vector file extension SVG, EPS, EMF. So these are the vector files, and the raster, which we are familiar with the raster size. Images are best for complex image like photographs, or are most likely to be widely compatible file format. You know that the JPG format. We are familiar with the JPG. How raster image lost there and become increasingly blurry when enlarged. So when we enlarge a image, raster image, so obviously it make unclear or blurry. Although vector image can be saved as a raster image, It is not possible to convert the raster image into a vector image. But as we discussed, on vector file, a vector image can be converted to the raster sites, raster file. It has some disadvantages. That is, it may lose the vector quality, but a raster file cannot be converted to a vector file. So raster file saved as vector file format will still be raster files. Most image on the web are raster files. Nowadays, we are familiar with the raster files, and some common raster file extension are, we are familiar, some of them you see. JPG, we are already familiar. Compressed raster format, often used in photos, best for web use, small in file size, compatible with most software. So most image on stock photography website will be downloaded as JPG files. PNG also, the raster format good for illustration of the icons, support transparency unlike JPG, best for web use, are smaller in size. So these are the some extensions we are using in case of raster sites. So besides the uh, vector and raster, an image can be classified in the basis of color. Uh, on the basis of color, the image can be classified into following categories: monochrome image or image which are the color component is absent. They are further classified on grayscale. As we discussed, gray label values, grayscale, it has only two values. Uh, that is zero grayscale image. The term grayscale refers to the range of shades between white and black. And there is a, we'll discuss on more what is gray label values. So there is a range is given to that image, that is a uh, range from 0 to 255. Grayscale image. The term grayscale refers to the range of shadows. As we discussed, there is a range between white and black or vice versa. And this is monochrome image. And as we discussed, such image sets may be gray in the 8 bits. So that is why it is a maximum is a 2 to power 8, 256. It's not 28. It is 2 to power 8. It is 256. So are enough to represent the grayscale because human vision system cannot distinguish more than 32 different gray labels. And the additional bits are necessary to cover the noise margins. So the important of some important example is most medical image such as X-ray. You see the X-ray value, X-ray. There is no color component. Please recall the X-ray report of a patient that does not contain any color component. Yes, yes. Please write your registration number and name in the board so that I'll give you attendance. So the X-ray, CT scan image, MRI, ultrasound image, all these medical reports does not contain any color component. These contain only white and black, gray values. The different only black and white, where there is very deep or very uh, um, uh, uh, other colors. It does not contain other colors besides uh, black and white. And you see, you may mark that this black and white. Some in some portion the black color is more, that is deeply black, and something it is lightly black, and that is there are different gray level values. But all these medical reports does not contain any color component. You will not get any red color, you will not get any blue, green, or any other color in these medical reports. So these are the example of your gray label values. So as you know, the monochrome image are associated with a range of values 0 to 255, which are not given. That is, we'll discuss about that. But the binary image are just special case of the gray level image, where the process is thresholding is applied. Thresholding is a process. We'll discuss how the thresholding is applied. We have a slides. What is thresholding? The technique we'll discuss about after 7 and 8 slides. The thresholding is a method which is applied, and all the pixel values have two values only, either 0 or 1, either black and white. There's no other values. But in a monochrome image, this the black and white, and there's a deep black, light black. There are different level of black and white. But here, a picture contains only 0 and 1, either a black color or a white color. There no other color is allowed. So it depends on 0 and 1. Because we applied here a technique called thresholding. What does the thresholding do? Thresholding convert all the other colors, all the other components either to 0 or 1. We'll discuss about that. Thresholding is only one bit is sufficient to represent the pixel value. Only one bit, either 0 or 1. But a monochrome contains a range 0 to 255, 256 value, 256 distinct value. But the binary image only has two values, either 0 or 1. So far we have discussed what is an image, what is a digital image, what are the components, the pixels. It has two values, its location and its value, xy and f of xy, and the type, vector, raster, monochrome, color, and your binary. Now, processing, digital image processing. Why? What is the digital image processing, and why do we need it? Why we need it? Why digital image processing? So DIP here is processing of image, means a digital image, which are digital in nature by a digital computer. Take examples. Take a small example. Suppose you are capturing a picture by your phone camera. Suppose there is a tree. You are going to capture it by your camera. That is your analog tree is an analog image. When it comes to your screen, it now becomes digital. It has some pixel value, and it is so it is processed. There's some technique, it process it. How do you know it is processed? Because the size of the object is not equal to the size of the object. It is mapped. The height of the tree, actual tree, is greater than your image tree in your screen. But the entire tree is comes to your screen. The screen size is too less as compared to the size of the tree. So that image is processed, then come to your screen. There are different techniques for the processing. So when we capture an image, first the image is analog. The tree is analog image. Then it is processed. After processing, you will get a digital image, and it comes to your screen. Now you can view it, you can edit it, you can increase its quality if the quality is less. Now you can use that tree in different ways. In your project, in your requirement, you can use it. So that is why the processing, we need image processing. When we process an image by using any digital computer, a digital image, we cannot process in an analog computer here, analog image here. So a digital image when processed in a digital computer, it is called digital image processing. The question comes, the question comes, why we need it? Why we need it? The answer is, you see, improvement of pictorial information. That is, uh, as we discussed, the size of the tree is more bigger than your screen size. How it comes in the screen? It is processed. It is processed. Efficient storage and transmission. So if you process it, you can store it. You may squeeze it size. A mu NL is the size. If some part is blur, if some part is unclear, you can recover it. You can increase the quality of an image after processing. Suppose an image is not clear, it is not visible. You can, there is some technique, you can increase its quality. And another important thing is, suppose you capture a picture of an elephant. Suppose there is a animal, there is an animal elephant. You capture the picture of elephant, but you are interested to study one part of the elephant, not the entire body of the elephant. Suppose the ear. Suppose the ear. So you can enlarge the ear part and only cut that part, and you can remove the other parts if you are not interested. We are only interested to study the component of the ear of the elephant, how it looks like, how it works, and you need that ear only, not the entire body of the elephant. So you can do it. So this is the some reason. These are some reason we have discussed. We need DIP. We need processing. We may increase the quality. We may take the parts of the image which are interested in by removing the other parts. And efficient storage, we may squeeze it. Suppose the size is more, we can may squeeze it and store it and transmit it. We can send an image from one place to another place easily nowadays, you know. So this is digital image processing, and these are the motivation. The motivation is improvement the pictorial information, obviously, and efficient storage and transmission.
Sir, are you available in Hindi as well?
So, sorry.
Can you?
Actually, I cannot hear you. Can you write in the board?
I said, sir, can you please explain these in Hindi as well, like
Oh,
wherever required? Because
yes, yes, yes. Okay. Digital processing, we require it. हम चाहिए उसको to improve the quality and efficient storage. You can store it easily. Why? Because we reduce the size. हम size उसको घटा सकते हैं, बढ़ा सकते हैं. So that is why uh, uh, the DIP is required. What we have discussed here, all the points are written. Digital image processing nothing but a method है. We can convert an image to digital form and then make an operation. Like you take the picture and make it some changes as your need. That is the processing. In order to get an enhanced image, you can increase the size of the image. Size तो you can increase बढ़ा सकते हो. और extract some use. This is important. Extract some useful information from it. As we discussed, we are interested in some part of the image, so you can extract that part only. And it is a type of signal dispensation. We'll discuss about the signals, digital signals and analog signals, because image is associated with signals. It is among rapidly growing technology today, which is application various aspects of business image. Image processing from core research are within area within engineering and computer science. इसका application बहुत ज़्यादा है. Nowadays it is बहुत popular है. It is very popularly used. Uh, um, Image processing, different techniques are used for that purposes. क्यों चाहिए? Why digital image is required? क्यों पढ़ेंगे हम DIP? So these are the requirement. So improvement of pictorial information for human interpretation. Processing of image data for storage, transmission and repression for autonomous machine perception. हम स्टोर कर सकते हैं, सेंड कर सकते हैं इजीली, and digital image can be sent. So these are the requirement for digital image processing. ये डिफरेंट लेवल है इमेज प्रोसेसिंग का. यूसी एक लो लेवल है, मिडिल लेवल और हाई लेवल. So in low level processing, if you input an image, you will get also output an image. A image input, output also image. So noise removal or image sharpening. Some noise if contains it. Suppose when you take some image, it may contain some noise. Noise in the sense, some pixel value missing, some part is unclear, clearly visible नहीं होता है. Okay, so that means that noise should be removed in the low level process. Or image sharpening. Image sharpening, as I told, that is some image value is missing, and some image, some pixel value is missing, some pixel value is spurious. Okay, that is it can be in low level processing, it can be modified. You come to second part, middle level process. The input is image, but the output is not image. The output is attributes. Okay, and the example is object recognition and segmentation. So these are some process, middle level process, low level process, high level process. We'll discuss details, but this the middle level. Only you remember that is the input here is the image, but output is some attributes. We'll get some attribute, not an image. Similarly, high level processing is input is attributes, which are the output of the middle level process. मिडिल लेवल प्रोसेस में क्या मिलता है? एट्रीब्यूट मिलता है. दैट एट्रीब्यूट इज इनपुट इन द हाई लेवल प्रोसेस. Whose output is understanding. That is, we will understand a picture. We will get information of a picture. why do their pixel is the picture is there.
So can I ask you? So
Yes, yes, why not?
in image processing, we are now in advanced like topics like we can now generate the images in AI systems. Like
Hmm.
if you have right now, so in
Hmm.
few of the levels, in which category we can put these
Hmm.
image generations?
In which level? No, no,
Do we have any other level which these are also in image generations?
yes, actually, in basically we are in a high level.
Do we have another we can categorize?
Now we are now in some high level process. That is low level, middle level are not nowadays used. Nowadays high level process are used. Okay, no, what are the process using? We'll discuss about the different process, different high level process are using DIP. This is the first class, so we have to what is DIP? Why we need DIP? But in coming class, we'll discuss what are the process, what are the
Correct.
process used for the high level process. Okay, so now we are in high level process. Okay, now we are not inputting an image and getting another image, and only we do not need only noise removal or image happening. So it is also important that what do you need? What do your project need, or what are the requirement? If your only requirement is only noise removal, you can use low level process. Okay. Or you will get any more information in some important information. You will get middle level or high level process.
So,
Okay.
like as of now, we can understand that Google Map is using the scene of understanding the
Hmm.
autonomous navigation.
Hmm. Hmm.
We can take that example as well. So it
That is
shows the
yes,
high
yes, yes.
traffic on the map. Yep.
Obviously, that is you can view that autonomous navigation. So the purpose can be divided into these five categories: visualization, observe the object that are not visible. As we discussed, some pixels may be spurious, some pixel may be lost its original values, because when an image is communicated, and when an image is sent, suppose you are sending an image to your friend. When an image is transmitted through its way, it may be affected some external parameter like your some magnetic field, some electric field, which is may be affected, whose quality may be affected. Okay. So that means that can be adjusted, that can be modified, because while a image is transmitted through a large distance, this quality may affected. Image sharpening and distortion to create a better image, to increase the quality of an image. Image retrieval, seek for the image of interest. As we discussed, you are only interested in some part of the image, not the entire part. So image retrieval, you can retrieve the image of that part only. Measurement of pattern. So measure various objects in an image. Different pattern are there, different pixel are there, which content of pixel. You can measure that of various objects. Image recognition, distinguish the object in an image. So these are five processing. So you all please write your name and your registration number for attendance. So analog image processing, you see, we are not interested for that. We are DIP, the digital image processing. In this type of processing, the image are manipulated by electrical means. by varying the electrical signal. The common example include the television image. So analog image processing is not our aim. So digital image processing, it helps the manipulation of the digital image by using computers. The three general phases that are all types of data have to undergo while using digital techniques are pre-processing, enhancement and display, and information extraction. As we already discussed, pre-processing, enhancement of the and display, we can view it clearly, and information extraction. So these are the need of the image processing. You see here, you see the representation by T, and T is the analog image. So when we convert to a digital, so it stands for zero. You see the position of zero. It exactly looks like a T, which contain the black color, and the ones around it, it represent the other color. Uh, you will be more clear to come to the another image, an analog image and digital image. But you see, in digital image does not contains white and black color. There are some black color which is deep black, and the white color also the intensity is white are different. You see there are some white clear and the white deep white deep black, some light black, and whites are also, that means different gray level values. And as we discussed, these gray level values, there is a range from 0 to 255, and that image contains that is the pixel value whose value is nearer to 0, it is more darker, and a pixel value which is more close to 255 is more lighter. Suppose a pixel value with 5 and a pixel value with 250. So the pixel value which is 5 is more darker, ये ज्यादा डार्कर है, क्योंकि जीरो ब्लैक कलर है, वन व्हाइट कलर है. Similarly, 0 is your black color and 255 is white color. So 255 is pure white and 0 is black. And if we go to in any between, any value, any pixel value having values in between 0 to 255, suppose 150, 250, 175, 205 is neither darkest or whitest, not most white. It contains any other combination of some black and white. That is the pixel value which closer to 255 is more lighter, more brighter, and the pixel value which is closer to 0 is darker. For example, a pixel value having 5 is darker than a pixel value of 250. So you see, uh, the pixel value contains 56, 50, 17, 56. So these are the different pixel value, but within the range 0 to 255. So so these are the different gray level values. As you know, the gray level values are different from there's a range from 0 to 255. You see the different gray level values are there. So technically, what digitization of an image nothing but it contains of two things. The process is one is sampling and another is uh, quantization. So the digit image digitalization consists of two processes. One is sampling, another is quantization, which is required to convert the analog signal to digital form. The digital image process is performed using digitizer, and the digitalization process consists of two steps. One is called sampling, another is quantization. So let us discuss what is sampling and what is quantization, because all the image processing digitalization process consists of two major component or two major two major steps. One is sampling, another is quantization. What is sampling? Sampling refers to the considering the image only at the finite number of points. Each image sample is called a pixel. That is its location. You can tell that that is the image location is sampling. To find out the location of an image, the sampling is a process to considering the image at finite number of points. That means where it is location, where the particular pixel is located, and sampling the process to locate that where that process where that particular image pixel is situated. As you know, every pixel associated with two things. One is gray labels, sorry, locations and gray label values, xy and f of xy. So here the sampling is referred to x of xy only, where the location is. Second, quantization the other one, that is the gray label value f of xy. You see, yes, that is the same thing is written here. It is referred to the representation of the gray label value, and this gray label value is a range from 0 to 255, where 0 stands for the black color and 255 represent the white color, and the other values in between this is the combination of the black and white, some lighter, some darker, some lighter, some darker, like that. That is the pixel value closer to 0 is darker, the pixel value closer to 255 is lighter. That is gradually, if you go from 0 to 255, the pixel value, that is the image darker, decreases, and finally it converted to pure white color when it reaches 255. So gradually it is decreases, that the darker value decreases, and 0 is the darkest. So sampling to get the location, quantization to get the gray label value f of xy. So it is not required when we capture the image, as you is already told, that is when you are capturing something by your camera. The camera may be in camera, maybe in digital camera, or maybe on phone camera. So the image you are taking, that is analog. That is your analog. When you capture the image, that is the that is analog. So when you capture the image, so it is in analog form, and when we convert it, that is the image sensor to send the incoming light from the image. Image sensor convert the incoming light from the object into electrical signal that can be stored in viewed later. The analog signal are continuous and the image are stored in the analog form. So when we take the image from a particular in your phone, it is in analog form we have discussed, and we cannot process analog image by a computer. So that is why we need to convert it to a digital form. Analog signal contain infinite points and continuous, and we need infinite memory to store them. This is the disadvantage of analog image. That is why you need a digital image. It is signal contain infinite points. We need more memory to store them. We need to convert the analog image into digital image to store and process by a computer. So that is why we have to convert this analog image to a digital image. How to convert we'll discuss, but the need of conversion is like that, because analog images have some demerits. So that is why to avoid that we have to convert the analog image to the digital image. So let us see how the conversion worked on, how the conversion uh, from analog to digital is done. An analog image is converted to digital image by digitalizing the analog signal. We apply sampling and quantization to analog signal to convert them to digital form. So we need, as we discussed, two processes. One is sampling and quantization to convert the analog signal to the digital form. A digital image is formed by arranging pixels in rows and columns. We know that our basically a screen, a computer screen, your mobile phone screen are consisting of, that is, rows and column, and each pixel has a particular integral value. The computer processes that integral value and shows that pixel. The arrangement of the pixel from the digital image. So we know that digital image, the main component, the smallest component is pixels, and it has some value, particular integral value. Every pixel has integral value. uh, from that value, that computer uh, shows that pixel to us. You see, we have two process: sampling, digitizing the coordinate, as you discuss. Sampling means location. The coordinate system will discuss where the particular pixel is. Always sampling refers to the location, and quantization refers to the amplitude value, gray label value, color value. Don't confuse, the both all are same. Intensity value. So digitization, the amplitude value is called quantization. So sampling refers to this, and quantization also refers to its value. That is, sampling refers to x, y, and quantization is to convert a continuous image f of xy into digital form. We have to sample the function in both coordinates and amplitudes. And we have to sample the the function of the not only the coordinate but also the amplitude. So we need two process, sampling and quantization, to convert a analog uh, analog image to digital image. You see, the first image shows an analog image A. In A, it shows an analog signal. In B, some technique used, some sampling function used. That is, we know that the first process is sampling. So that function used for sampling. And digitization, after that, after two process, we get a digital image. You see here. The basic process is analog signal. First is sampling and then in digital signaling. But some rare process use fast quantization, then sampling. So there's some analog signal, you see. So we use fast sampling to get its location. So after sampling, we get the location of all the pixel. You take from the left side arrow. So after sampling, um, it is converted to, we get the exact location of all pixel, and you see then quantization, and after quantization we get the all the color, all the gray level value of all pixel, and the final picture we get is nothing but it is a corresponding digital one. So in this way, the analog signal can be converted to its digital signal. And in other way, if we first quantization it, we get the colors, and then sampling it, you get the location. But the basic way is first sampling and then quantization. So as we discuss, the basic is first sampling. So after sampling the analog signal, we get the location. Once we get the location, then we need its gray level value. That can be done using the quantization method. So quantization is done by rounding up the amplitude of each sample and then assigning a different value according to its amplitude. Each value will represent a different color tone. So it is we get this color. So once you get the location and the amplitude value or gray level value, its color. Now it is represented in, it is shown in a picture, and the picture we got after these two process, sampling and quantization, is a digital one. So now now in this way we can convert a digital image, sorry, an analog signal to digital signal. Uh, Please write your name and registration only. I will give the attendance. You need not to mark any attendance. So you only write your name and your registration number. I will give the attendance and send to your RC. So okay, and send. I will send you to the LC. So these are the common difference between sampling and quantization. As we discuss again and again, determines the number of pixel of a digital image, and it determines the gray level value, tone value, intensity value, amplitude value. They all are same. Do not confuse at all. Sampling digitalize the x-axis of an analog signals, and it is y-axis because it is value. The amplitude value of the analog signal is recorded at the regular time interval. The amplitude value are recorded up at a given value because the amplitude value may not change. Done prior to quantization. So as you know, the basic step is first sampling, then quantization. Some rare case you may first quantization, then sampling, but the basic is first sampling and then quantization. So that is why it's done prior to quantization, and quantization is done after the sampling. So these are the major difference between sampling and you may get a question, what is sampling and quantization. So you write with an example, and do not forget to write these differences. I will send this PPT to your to you. You may uh, follow it. You may refer it. But during conversion, during DIP, we will got some error. We'll get some error in every uh, uh, conversion, or a software may produce some error. You know that you may now watch some IPL. The DRS system, DRS system. You can you tell it is 100% correct? No, it also contains some error. What are the size of error may be? The size of error may be small, but this process contains some error. Okay, that is the bounce, the direction, it may contain some error. Okay, the player may suffer some that error, but there is some error. Similarly, also here in digital image processing, when you convert a analog to digital image and when you make processing it, there may be you get some error. So one type of common error is pixelization error. The pixelization error is one type of common error. Let us discuss what is it. The size of the pixel is important for image quality because you know that an image is consist of pixel. The quality, the size of a pixel depend upon the quality of the picture. Okay. If the size is very large, there will be lesser number of pixels because your screen size is fixed. You cannot increase your size of your screen. Your mobile screen, your camera screen, your mobile screen, your computer screen is fixed. There is no option to increase or decrease the size. So when you're capturing an image, if the pixel size is more, your picture contains less number of pixels. Your image contains less number of pixels because size is more, size is larger. If the size is smaller, your screen contain more number of pixels. So if the pixel size is more, the size is very large, there will be lesser number of pixels, obviously. Because the size of the screen is fixed and the size of pixel is okay, so it is pixelation error. Where the gray label discontinuous edge of the pixel become poor. So if the number of pixel is more, the detail becomes less. That is, the quality is less. If a image contain more number of pixels, the quality is better. So are the size of pixel is more or greater, it contain less number of pixel, hence the detail become less, which makes the image distracting and meaningless. This is called pixelation error, where the gray label discontinue at the edge of the pixel become poor. That is, you will get a blurring picture, you will get a unclear picture. Okay. So what is the solution? What is the solution? If there is a pixelation error, how to recover it? How to overcome it? The question here: what should be the ideal size of the pixel? Should it be bigger and smaller? What is the size of pixel? So that we can tell that is our pixel size should be ideal, and the pixel size should be good for our picture. The answer is given by Shannon-Nyquist theorem. There is a theorem known as Shannon-Nyquist. As per that theorem, the sampling frequency should be greater than equal to 2 into f max. What is f max? F max क्या है? The highest frequency present in the image. Highest frequency, highest amplitude value multiplied by 2. Otherwise, the original signal cannot be reconstructed. Okay, so the frequency value should be equal to 2 into f max. Let us take an example. What should be the physical size of a 2D image of a document with dimension 2400 cross 2400 when scanned at 300 dpi dots per inch? 300 dpi. Here dpi stands for dot per inch. You know, we are scanning 300 dpi and the image whose dimension is 2400 into 2400 pixel. The physical size of image, number of pixel in width by resolution into number of pixel in height by resolution, means 2400 by 300, 2400 by 300, 8 inch into 8 inch. So if the physical size of image is 8 into 8 inch, then the sampling resolution is 5 cycle per mm. Then how many pixel per cycle are required to have the better quality with an image? of 250 size analog. So we should a physical size to be 8 to 8. It is the first question. The answer is the first question is the image size must be 8 into 8 inch. Okay. Acha. Another question is added there. An additional question. The sampling resolution is 5 cycle per mm. How many pixel per cycle are required to have better quality image? How many cycles? How many pixel per cycle? You see, the solution is 5 cycle. Therefore, better quality 2 pixel per cycle are required because it is 5 by 2, 2 by 5 pixels are required. 2 pixels. But my question is, will an image of size 256 into 256 be enough? 256 or 256 enough की देखेंगे. This is because sampling theorem states that the sampling frequency should be greater than the twice of maximum signal frequency. This means that 10 pixels, because 5 pixels are 10 pixels. 10 pixels per mm is required. So the pixel size 0.1 mm. It will be noted that the double rate of the both the directions is called Nyquist rate. The given that the image size is 1 is 2.54, 8 into 2.54, 8 into 25 maximum 20 into 3 to 20 into 2 to square mm required. So therefore minimum number required pixel is 2032 into 2032. So an image size of 256 256 is not enough. ये enough नहीं है. So the sampling size 256 256 is not enough because we need at least 2032 into 2032 pixels. If the pixel cycle is 5, so it twice is 10 pixel. So if 10 pixel is there, so that means we need 1 inch is 2.5%. We know that. So 8 into 2.54, 8 into 2.5. Okay. So image resolution we will start from the next class. So any question or query you can ask. No. So please wait 1 minute. I will give I will take an image or screenshot. Uh, those who have not written, please do not write again and again. Those who have not written your registration number and name, please write in the board.
Sir, how many questions came regarding example 1, 2?
Now you will get 1 or 2 questions from it. Okay, what is resolution size? You will get some question. You can see the previous question. You will get 1 or 2 questions.
Okay, sir.
1 minute, please. I will take the screenshot. Okay, thank you all. If you
Thank you, sir.
okay. So okay, so let us leave and meet you in the next class. Thank you.